Okay, so first we're looking at solving compound inequalities. And this is something that the students are kind of familiar with already. They just don't see it that way at first. So when looking at our standard algebra 5.0, we've learned how to solve multi-step problems. Okay, we've learned how to solve word problems, and we've also learned how to solve linear equations. But now we're focusing this chapter on linear inequalities. And we've also been able to justify our steps, meaning we're able to say, let's distribute, let's simplify, let's combine like terms. That's what they mean by justification. So here our objective is that we'll be able to solve for compound inequalities. Okay? When we first started out, we talked about how a compound inequality consists of two inequalities joined by and or or. And so I told you to focus on and as like an intersection. And so I showed you a map of our school with Cougar Way and Beaumont Avenue. So where Cougar Way and Beaumont Avenue meet is an intersection. Okay, then we talked about union as leaving a part out. So I focused on our freeway that runs through Beaumont, and I said that it separates really west side of Beaumont and the east side of Beaumont. And Beaumont does not own the particular freeway that runs through it. So I said that little area is left out, and that sort of represents a union. So there's a gap in the middle. Okay? So also, when you think of an and, I want you to think of on a graph, okay, let's just say this is -5 and this is +5. Obviously there would be numbers in the middle, but you're going to have, with an and, it's going to be joined in the center. Okay? Now with an or, you're going to have a number line, and let's say here's -5, sorry, and here's +5, but instead you're going to have it go in opposite directions. So that's another way of looking at and or. And is going to be joined in the middle, or goes in the opposite direction. See where there's a gap in the middle? That's the or. Here it meets in the middle, and that's what an and represents. Okay, so we also talked about, I gave you some examples, but let's first talk about turning verbal phrases into inequalities. And I'm just going to do one because we did several of those in class. But the first one, it says all real numbers, okay, so I could say x less than -1. So less than -1. Or all real numbers x that are greater than and equal to 4. So that's how we would translate that. I'm going to go ahead and show you this one because it is an and problem. So all real numbers x, and they have to be greater than -3 but less than 5. Okay, I like to lay mine out as if it were a number line. So I put my -3 over here and my 5 over here. This is only on and problems. So it's saying it has to be greater than, x has to be greater than -3. So I draw my greater than sign. And it has to be less than 5. Notice how the inequality signs are facing the same direction. That's another indicator of an and problem. And you'll also have your variable or your problem in the middle. All right, let's go to a problem that I can actually show you how to do this. So there's a couple different ways that you can do this, and what I'm finding is that students prefer one method over another. Okay, the first method I'm going to show you is where you work both sides of the inequality at the same time. So if I have x plus 5 and I want to get x by itself, I want to isolate x, I'm going to subtract 5 from both sides. Okay, we're going to draw our line, bring down the inequality sign. So put those here. Now I've just canceled out my 5's, because if you have a positive and a negative 5, you have 0. So now I have x in the middle. 9 minus 5 is going to leave me with 4, and 2 plus a negative 5 is going to leave me with negative 3. Okay, so if I go to graph this, and I'm going to make this kind of simple for time's sake. Here's negative 3, here's 0, and here's 4. Okay, notice this does not have a line on the bottom, so it should be an open circle at 4. And x has to be less than 4. So I know that my arrow is going to start, or my line is going to start in this direction. Over here at negative 3, it does not have an equal sign as well, so I draw the line. And then again, x has to be greater than negative 3. So this is in this direction. So you can see where this and problem meets in the middle. All right, now another way that my students like to do this is to break it up. And so let me clear this, what we have so far. So they like to take this problem and go 2 is less than x plus 5, okay, completely ignoring this side. And then they take x plus 5 and set it less than 9. Okay, again over here we subtract our 5, draw our line, and bring down our inequality sign. Okay, a positive 5, negative 5, those cancel. We're left with x. 2 minus 5 leaves negative 3. Okay, on this side, again we subtract our 5 and subtract our 5 again. Draw our line, bring down our inequality sign, and 9 minus 5 gives us 4. These cancel out and we're left with x. Now in graphing that, hopefully you can see where if you brought those together with x in the middle, less than 4, just moving this over and moving this over, but only one x, negative 3, and that inequality sign, just moving it over here. Okay, again, here's 0, here's 4, and here's negative 3. This inequality sign does not have the line underneath, so it's not equal. So we're going to put open circles on both of those. X has to be less than 4, so we draw it this way. And here, x has to be greater than negative 3. So they will connect in the middle. Okay? Let's go to our next one. Now I'd like for you to pause this and give this one a try. Okay, so now we're back. Hopefully your answer is going to look just like mine. So I'm going to do it the first way. Negative 7 is less than x minus 5, which is less than 4. And I'm going to add 5 to both sides. Again, bring down your inequality signs. So we've got those. Now over here, 4 plus 5 gives me 9. These two 5's cancel out, a positive and a negative. So I'm left with x in the middle. So we've managed to isolate x. Now I have negative 7 and a positive 5. Well, I have more negative, so I subtract my 5 from 7, and I have negative 2. So on a number line, let's just say here's 0, here's negative 2, and somewhere out here is 9. Okay, again, this is a less than sign, not equal to, so I'm going to put my circle there. Over here at -2, it's a greater than, x has to be greater than, but not equal to. So I'm going to put an open circle there. If x is less than 9, I know that my line has to start going in this direction. And if x is greater than -2, I should be going in this direction. And that's where you get them to meet in the middle. All right, let's see if we have an OR problem. So let's take number 2, okay? And we're really going to work them out as 2 separate problems. So I'm going to subtract, I'm going to subtract 1 from both sides. Bring down my inequality. -5 minus 1 gives me -6. And then these cancel, and I have 3h. To get h by itself, these are being multiplied, so I'm going to divide by 3. Now, I divided by a positive, so I don't have to flip the sign, so h should be less than -2. And I'm going to write my OR sign here. Now let's work on this problem. I'm going to add my 5 to both sides, draw a line, bring down my inequality sign. 7 plus 5 gives me 12. These cancel, and I have 2h. To get h by itself, I divide by 2. And h is greater than 6. So when I'm drawing, I'm going to do this up here. When I'm graphing this on my number line, and let's see, I'm going to need, here's 0, -1, here's -2, and then 1, 2, 3, 4, 5, 6. Okay? So, looking over here, h has to be less than a -2, but not equal to. So I'm going to draw an open circle, and if h has to be less than -2, the more negative I go, the smaller it gets. Okay? H is greater than 6. It's not equal to, so again, an open circle, and h is greater than 6, so I have to draw my arrow or my line this way. Notice in an OR situation, we have this open area here where it does not meet up in the middle. Okay, so hopefully that has been helpful. Our objective was to learn how to graph compound inequalities.